What is great design? What happens when art, science, math, and aesthetics come together? We often assume these areas of study are in completely different categories. Whether in school or the office, let's be honest, art people and science people rarely get together, share food or ideas. Why is this? And has it always been that way?
Science, math, and art have a deep, long relationship, longer than you can even imagine. And I can prove it to you using a simple, powerful idea that connects everything from Da Vinci to modern architectural design. It's a simple, underestimated tool, the golden ratio.
First, let me explain what the golden ratio is, or as Da Vinci would have called it, the divine proportions. The easiest way to understand the golden ratio is through a sequence of numbers called the Fibonacci sequence, introduced in the modern world by Italian mathematician Leonardo of Pisa. Basically, the sequence goes like this. You add the first two numbers, 1 plus 1, and you get 2. And then 3 plus 2, you get 5, and then 5 plus 8 gives you 13, and so on. Pretty simple idea. The sequence literally never ends. When we take any two successive Fibonacci numbers, the ratio is very close to the golden ratio and can be visualized as a spiral. One of the most obvious places you can see the golden ratio is in nature. Interestingly, and I imagine many of you out there don't know this, but these Fibonacci numbers correspond to the number of petals on a flower, seeds in a pine cone, and even spirals in a sunflower. The history of the golden ratio goes back far beyond Fibonacci in the 1200s. In fact, it's believed that the ancient Greek sculptor Phidias used the golden ratio around 480 BC when he sculpted the statue of Zeus at Olympia. And check out how the ratio is used at the Parthenon. 1 and 1, 2, 3, 5, 8, 13, boom, check out the golden ratio. However, to talk about the golden ratio in history, we have to fast forward to the Renaissance, a pivotal point where science and art intermingled and quite literally changed the world. Florence, Italy was the epicenter of the Renaissance, with artists like Da Vinci, Donatello, and Michelangelo calling it home. Also in Florence, when you follow the money, you find the culture-loving, filthy rich Medici family who funded just about anything artists and engineers could dream up. I mean, who else would fund a 17-foot sculpture originally intended to be on top of the Florence Cathedral?
Mix all this with the development of the scientific method. Scientists to mathematicians now met in coffee houses to literary salons, sharing ideas, inspirations, and of course, arguing whether the world was flat, influencing the way we critically think about the world around us and how we design it. Creative collaboration begins, and the coffeehouse phenomena was born.
Artists like Da Vinci knew that combining art and science would allow design and aesthetics to go from good to divine. How do you do that? By using the golden ratio. In fact, Da Vinci was so convinced that this ancient tool was so game-changing, he illustrated a book written by Luca Pacioli called The Divine Proportions, which illustrated time and time again just how amazing the Fibonacci sequence was. Check out how Da Vinci used the golden ratio from the Mona Lisa to the Last Supper. The ratio allowed him to create perfect balance, focus, and symmetry. In fact, Da Vinci believed it to define what he called, quote, the perfect proportion man, a ratio artists had already been using throughout history. The golden ratio didn't just influence artists, but scientists as well. In fact, Nicholas Copernicus used the golden ratio to form his idea of heliocentrism, a concept so advanced it literally changed the way we saw our world and, of course, where it was in the universe. Fast forward to the 1800s during the Impressionist period, where the invention of the camera and paint and tubes pushed art in a whole new direction. Artists like Van Gogh knew the power of visual balance, which is at the core of the golden ratio, and in his most famous painting, Starry Night. Artists like Georges Seurat knew the power of the Fibonacci sequence, and is said to have, quote, attacked every canvas by the golden section, as he did here in his classic Bathers at Asnières. Fast forward just a few years again to the 1920s, where science, mathematics, art, and beautiful design came together at the Bauhaus. This is where modernism was born, with an emphasis on function and goal to bring art back together with the things we interact with every day. The Bauhaus changed the way we design everything, from groundbreaking design and materials used in the Wasili chair to the bold lines at Frank Lloyd Wright's Falling Water. It was also during this time that eccentric artist Salvador Dali was fascinated, like Da Vinci, with combining art, science, and mathematics. Dali was inspired by the Golden Ratio and used it in many of his famous paintings, including The Last Supper. You see how the golden spirals create perfect symmetry and move your eye from the subjects at the table to the arms in the sky.
Dali was so infatuated with the Golden Ratio, I had to come down to Tampa, Florida, to the Dali Museum so you could see for yourself. So Peter, I know that Dali was obsessed with the Golden Ratio and the Fibonacci sequence, so I've been so anxious to get down here to see and for you to let me know, how has it influenced the architecture design of the museum?
Absolutely. So it was one of those things that informed every level when we were planning this new building, all the way down to where right in front of us we have a golden spiral actually placed in this bronze all the way in the middle of this, in the middle of these pavers that are colored, so you can see that exponential, kind of expanse of the Golden Ratio. But definitely Jan Weymouth, everything that he's tried to structure here when he was building the museum has to do with the Golden Ratio and those perfect proportions that Dali was obsessed by.
Wow, and what I love about the building is, I mean, you have it inside, but also from the exterior, it's like that, the tech meets aesthetic. Like it's just beautiful mixed in with that Golden Ratio. Wow.
Yeah, it's both austere and at the same time incredibly delightful for the eye.
Well, and I love too on the plaque even out here, I just saw you've got a quote from him just about the Golden Ratio and how important it was to him and his work. And the size of this spiral, I don't think I really saw it from the picture I've seen, but man, takes the entire patio up. So has the influence with the Golden Ratio and the Fibonacci sequence, did it make its way into here as well?
Yeah, so out here we have these references to spirals and to the geometry that Dali was interested in. Inside we have a helical staircase that also references Dali's obsession with spirals, and it's actually a reference to the DNA molecule, the double helix spiral. So we have golden spirals, we have helical spirals. There's a lot of references to Dali's obsession with these forms.
Oh yeah. Can you tell me more about why Dali, I mean, I know he was obsessed with science, but what was it that got him so crazy about Fibonacci and the golden spiral and golden ratio?
I think Dali was just one of these people who constantly questioned things, and he was an ideator. He was constantly had a kind of creative perspective on everything. So when he encountered Freud became sort of a leader for him. When he encountered the writings of some of the scientists like Heisenberg, that became an exciting opportunity for him. Dali was constantly challenging preconceived notions and looking for different ways to look at something that we're always looking at ourselves. And so definitely the geometry and the kind of precision of that appealed to somebody who's constantly looking for order in nature.
And you got so inspired by Da Vinci, who obviously was crazy about it, wrote a book about it, so yeah.
Right. And Da Vinci, it's like Da Vinci wasn't his favorite artist. He probably thought that Raphael and Vermeer were better painters, but I think Da Vinci worked in the way Dali worked. Constantly a person who was tinkering, was trying to find the order of things, trying to find the origin. And so there's many times in Dali's life, he's really close to Da Vinci as an inspiration, and especially with the mathematics and geometry.
Oh yeah, well again, it's that obsession with technology, Da Vinci, and the aesthetics, something beautiful. And I mean, Dali did that same thing, is bringing a lot of that into his work.
Today, we now live in an age where we clearly see how mathematics, science, design, and aesthetics come together to create the world we now know. The Fibonacci sequence finds its way into everything from computer data structures and sorting algorithms, vehicle design, and architectural engineering. So, what is next? How can we keep pushing the limits by taking complex mathematics, engineering, and computing power and wrapping it into something so aesthetically beautiful, you almost forget what it's capable of wielding? That is precisely what the team at MSI is doing, where tech meets aesthetic. Limitless creative power blended with design principles that connect as far back as ancient Greece to the Bauhaus. That is the goal of the MSI Creator Z16. This is a computer for creators innovators, polymaths, and engineers, those who want to be inspired by the past but are fueled by the tools of tomorrow. Every design element speaks to the needs of your inner creator by giving you even more design real estate with a screen size of 16 by 10. Just look at what happens when great design meets engineering and mathematics in the past. Now, just imagine what you can do with a machine designed to do just that, accelerating the future through you.